Today our learning goal says, I can recognize misleading graphs and statistics. I'm not just going to trust that they are good. I'm going to make sure that they were put together well and it's not trying to mislead me. Because graphs are used to mislead people, believe it or not. So, bar graphs and line graphs. I want you to put a box around this because this is important. This is how they like to use them to mislead us. If the vertical scale does not start at 0, in other words, they just start at the bottom where 0 should be, and they start with, like a number that maybe will be the lowest, it'll represent their lowest value, but yet it's not really even close to 0. So if the vertical scale does not start at 0, the difference between the categories or time intervals can look larger than it is. So let's just look at this one right here, this clothing sales one. Looking at that graph right now. It looks like what is going on in the clothing sales for that particular store. So let's say this is, what's one of your favorite stores? Where to buy clothes at?
Shields.
Target? Okay, and yours is Shields. Okay. So what if Target, wants to prove that their competitor Shields, they're going down, their sales are going down. You know what, you shouldn't be shopping at Shields. We are it. We got this. Okay? So they're showing this graph and they're showing this is what's happening at Shields with their clothing sales. When we look at this graph right now, just look at the line segments, what would we assume is happening?
The one following better more than the other.
Now they had a really sharp decrease in clothing sales in that time frame right there. They had decreases going on, but they had a really sharp one during that time frame. But when you look over at the other graph where it's a corrected graph, is it really that sharp?
No.
No, it's not. It's not declining near what it appears to be in the misleading graph. Well, the other thing that is making it misleading is if the horizontal scale is not equal intervals, then the rate of change can also affect that steepness. So look at what's happening first of all. On the vertical axis, they started at 20,000 and they ended at 26,000. So they're really only showing a $6,000 in difference in clothing sales. And look what's happening on the x-axis. From the beginning to the first tick mark, it's 1 year. From that tick mark to the next tick mark, it's 1 year. From that tick mark to the next one, it's not 1 year, it's how many years? 2 years. It has to be the same all the way across. So notice after they corrected it, it does go 1 year at a time. And notice what happened on the vertical axis. Now they're starting at 0, and instead of starting at 20,000, they start at 0 and they go by 5,000 at a time so that they get a truer picture of the graph. So the vertical scale should start at 0. Horizontal scale and the vertical scale, both of them, need to go in equal intervals. So I talk about scale a lot. What is the scale? But like you tried to tell me on that last one that the scale was 10, and it was what instead? 5s. It was going by 5s. Okay, and then in circle graphs, here's what can happen in a circle graph. Let's put a box around that also. If the sections in a circle graph do not sum, that's kind of a funny way to say it, do not add up to 100%, the sections will appear larger than they actually are. So again, if you wanted to, have somebody just look at a circle graph and they see a really big piece of pie in that circle graph that is representing something that they want to prove is, you know what, look at here. Everybody's most favorite, their favorite food is not necessarily pie, but at the cafeteria is, let's say, it's Crispitos. Everybody's favorite food at the cafeteria is Crispitos. And when you look at the circle graph, it appears that, oh yeah, it looks like almost half of the students, that's their favorite meal. But yet, if all the sectors don't add up to 100%, it's not really almost 50%, it's going to be less than that. So this is actually the favorite school club is what this one is. And notice, what do they add up to in the misleading graph? What do these three pieces of the pie add up to? Add them up quickly.
60. 78%.
78% of the data is being represented instead of 100% of the data. So then it got corrected, and they accounted for the other 22%. So, you know, like oftentimes when there's like little amounts, like maybe not very many people are in a certain club, like only 2%. So they don't get their own piece of the pie. They get put together with another club that only 4% of the students are in. And then maybe another group that there's 15%. They get all added together instead of each getting their own piece of the pie. Okay, let's look at the one that we're going to analyze here. First of all, what's going on? The graph shows the number of men and women who have enrolled in a school. Okay, just right now, just taking a quick glance at that graph, the men are the shaded bars, the women are the unshaded bars. Just taking a quick glance at it right now, what are some of the things you could say? No, don't analyze anything right now other than the bars themselves. Just look at it and say, you know what? Looks like
It could be a fake graph.
looks to me like, you know what, from the year 2000 to 2001, something happened to the men. They quit going to school. Give me something else you see in that graph.
Just as 2002, the men's went up and also the women's went up.
Okay, what year? What?
In 2002,
Yeah.
the men's went up and the women's went up.
Okay, they both had an increase. Okay, from 2001 to 2002, both the men and the women had an increase. Who had the most substantial increase in that year? According to that graph, it looks like the males did, the men. Okay, what about the year 2003?
Women's dropped.
Not only the women's, but so did the.
Men, but the women's started more.
What did this school do in that year? Doesn't look like very many people wanted to enroll there compared to the other years.
Got rid of fast food.
Maybe. Okay. Well, this graph is misleading. Why? Let's analyze it. Why is it misleading? What's going on?
It does not start at 0.
Because it does not start at 0. I love the it, and it does not start at 0. What's it?
Bar graph. Bar graph does not start
No.
at 0.
The vertical axis. The vertical scale does not start at 0. We have to be specific. So let's put that, first of all. The vertical scale does not start at 0. Calvin, join us. We're writing right now. Is there anything wrong with the horizontal scale? What about the horizontal scale? Anything going on there? It goes up a year at a time, doesn't it? So is that legit?
Yes.
That's okay. Okay. So is there anything else wrong with this? How about the vertical axis then? Is it going, even though it doesn't start at 0, is it at least going by equal intervals? Because maybe they might throw that up in there too. Is it going by equal intervals? What's the scale that they are using on the vertical axis? Even though it didn't start at 0, what's the scale they're using? Ones, right? It's going on one at a time. So it does have an equal interval vertical scale. The only problem with this one appears to be that the vertical scale does not start at 0. Okay, well then what might someone believe because of this graph? I mean, apparently they were trying to throw somebody off.
They were trying to. They were trying to show that possibly during the few, like, 2001, 2002, women were more active in school.
So what was the first part of that about being active in school?
From 2001 to 2002, women were more active in school than men.
Not in 2000.
I said 2001 and 2002.
Oh, I thought you said 2000 and 2002. I'm sorry. So it appears that, so it throws off the, you know, the showing that there's a lot more women than there are men in those 2 years. Okay. So maybe, do you think that's possibly happening all the way across the graph, though? That it is showing bigger differences between the men and the women than there really is? Let's look at the year 2000. What's the difference in the number of men enrolled versus the number of women? What's the real actual difference? 2. There's 2 more men enrolled than women. 2. And it looks like a lot more than that, doesn't it? How about in the year 2001? What's going on in the year 2001, Calvin? How many more, there's more women, right? How many more women are there really, Calvin, in the year 2001 than there are men? How many? 4. Yeah, a whole 4. And it looks like there's a lot, doesn't it? It looks like, you know, it looks like it's probably, yeah, typically what we would look at those, we'd probably go by tens, wouldn't we? We would say, oh yeah, it looks like there's about 40, and it's a whole 4. So there's a much big, so what it's doing, someone might believe, let's put this, someone might believe there is a greater difference in the number of men and women enrolled than there actually is. You know what? It's not then. I think it's than. Than there actually is. So by looking at this, we might, you know, say, oh, you know what? There's quite a difference between the men and the women. No matter which year you look at, you kind of feel like, wow, I wonder why so much difference in that particular year. So who might want to use this graph? Why would somebody even do this? Who might want to use this? Okay, why would college use it? For what reason?
Say there's really, like in one school there's really athletic women there, and they show that there's more women that go to this school that are athletic than other schools, or than.
Okay, well we can't throw in the word athletic because it doesn't say anything about athletes here. Okay, also we can really, it's by enrollment. We're comparing men and women's enrollment.
It's showing that there's more women that enroll in the school than others. Possibly.
There's more women in a couple of the years, but then there's more men in a couple of years. What's the biggest thing that you hear on the news the most when somebody wants to, you know, like, say,
at this time, teachers, please put your recycling outside of your doors. Thank you.
this is not fair because there's inequality. Isn't that the thing we hear the most about the inequality, where there's inequality between races, inequality between genders, inequality between you know, income level, whatever it is. One of the things that they like to talk about is inequality. So would this possibly be used by somebody who wants to show that there's inequality between the gender of the admissions of this college? Maybe somebody wants to show that, you know what, they favor one more than the other, and not necessarily saying which one and which year, but it appears that there might be some inequality going on. So let's just say, who might going to use this graph? Someone wanting to show gender inequality at this school. I gotta get my recycling out, so I'm trying to write fast. Okay, when you have that written, go ahead and flip to the backside and start reading the information at the top of the backside, the next thing that we're going to cover. So this is misleading graphs. Now we're going to move on to misleading statistics. Okay, let's go to the backside. Okay, after you've read that, the top three things, I want you to be able to tell me what that really says. Because this is huge, right here. Put a box around it. If you want to get your way, you do one of these things. You make the sample biased, misleading. So give me an example of a bias. How could you make a sample biased if it only surveys a certain group of people? Can you give me an example of something that you're like wanting to prove this, so you're only going to survey these people? Cody?
Like, you find people that are really rich, really, really rich, and you ask them how many electrons they have. And they say there's 5 people, and they say, well, we have like 4 electrons. And then they use that as like, they say 5, so like 5 different, like, people, like, groups of people said they have this many.
So they make it look like everybody has a bunch of electrons, different devices at their house. And they survey only the rich, so they have lots. Understand? Okay, that could be bias. Give me another example of bias when you want to, so you're only going to survey a certain group of people. Oh, so Kelvin, you know what? He wants to prove that, you know what? The greatest thing among students here at Valley City High School is they say they are going to be farmers. He is like convinced that the majority of Valley City High School students they want to be farmers. That's what he decided. So you know what? But then I say, well then prove it, Calvin. Okay, you need to do a survey and let's find out if really the majority of the students at Valley City High School want to be farmers. How many of you in here want to be farmers? You're not going to be a farmer, really?
Maybe.
Oh, maybe. Okay. But you might want to be. Okay, so looks like about maybe 2 of the group here that want to be farmers in here. But then when Calvin goes out and does his survey the people because they know I just send them loose and let them go do it. Guess who he surveys? People who he knows live on a farm, work for their dad, and chances are that's what they might want to do someday.
Or you could go out to people that actually do farm.
Or you could just, that's kind of the same thing. So, he surveys the people that's their, it's likely that that's what it's going to be, and then it turns out that, the majority of them are. Okay? How about a sample is biased if it's too small? So I go to the school administration, and here's what I tell them. Okay, will you guys in here, will you tell me what is your favorite food in the cafeteria?
Burgers.
Country fried chicken.
No, one. No? Okay. Well, yeah. What? What'd you say? The breadsticks. Okay. Okay. So breadsticks are kind of popular. Okay, so I'm gonna go to the food lunch program, and I'm gonna say to them, you know what? I surveyed the students over across the street. So that I go over to our office and say, I surveyed the students across the street, and they want you to serve breadsticks every day. They love those things. They want breadsticks every single day. And she says to me, this is Mrs. Hagan, she says to me, really? What, the majority of the students? I'm like, yeah. How many students did you survey? Oh, I surveyed 7 in my algebra B class. And 5 of them said, they wanted breadsticks every day. And would that be a big enough sample size for her to really justify serving breadsticks every single day?
Every single
So you need to, Yeah, and you need to be random about who you pick besides, okay? And then the last one is, statistics can mislead if the measures used are not a good representation of the data. We know what measures there are. There's mean, there's median, there's mode. Okay, those are the three measures that we probably would typically use to help us be able to decide. So I'm gonna leave you guys that to study. Let's do this one. Number 2, houses on Main Street. We would call it Central Avenue here. Sold for the following amounts: $175,000, $182,000, $178,000, and $389,000. Explain why the following statement is misleading. Houses on Main Street are selling for an average of $231,000. Would you check it out and see if that is the average of those four? Would you check that out? By the way, there's a shortcut to that. You don't really have to take it all as real. You can try something else. There's 4 data values. Is the average really 231,000?
Yes.
Sorry, is it? Did you do it? Yeah. By the way, you could do this one shortcut. You could do 175 plus 182 plus 178 plus 389 divided by 4 and stick 3 zeros behind your answer. Is it 231,000? Okay, so that's not the problem. They did not find the average wrong. So you can't say, oh, they found the average wrong. No, they didn't. We just verified that it really is. Houses on Main Street are selling for an average of $231,000. What's the problem then? By the way, it doesn't say how big this town is or anything. It could be the smallest little town, and on Main Street, they only have these 4 houses. So I don't know that we want to say it's the sample size, because we don't know where this is. If it's Fargo, that would be a problem. We know there's a lot more houses there on Main Street, probably. So what's the problem here?
It doesn't tell us how many times.
Why is it misleading? It's giving the mean, you guys, right? It's giving the average. So what's the problem? You just zeroed in on it right there. 389,000. What do we call that again in this data set? Yeah, the 389,000 is an outlier. The others are 175, 182, and 178,000. They're only a spread of how many $1,000?
They're probably using one of the higher ones and one of the lower ones.
At this point, what we're trying to figure out is why should we not say that the average of a house that's selling on Main Street is 231,000? What's the problem? How many of those houses are even selling for that much? Only one of them. The other 3 are not, are they? They're way under that. They're about $50,000 under that. So is that a good representation? Is the average a good representation of those data values? No, it's not. So what we're going to say here is that basically what happens is that 389,000, so we're going to say 3 of the houses sell for less than $231,000. 389,000 is an outlier. And makes the average what? What does that do to the average? Makes it higher, doesn't it? Yeah. Makes the average higher. So using the mean is not a good representation of the average or of the selling prices for these houses. What might be a better one? Would the median? Think of putting these in order and finding the middle. What 2 would be in the middle?
Would be 78.
So 178.
And 172 or 82.
Yeah, 178 and 182. What's the middle between 178 and 180,000. 3 of them are around the $180,000 mark, whereas that outlier is not, is it? So the median would be a better representation. How about the mode? Does this one have a mode? This one doesn't have a mode, so we couldn't really use that. Okay, a researcher is contacting people by email to see what proportion of them use a computer every day. Okay, there's something really critical there. How's he contacting them? By computer, email. Email, if you're going to do an email, you're doing it on a computer. In your phone is a computer. Don't say, well, I would do it, maybe he's doing it on his phone. Explain why the following statement is misleading. 85% of people use a computer every day. This is a biased sample. This is a biased sample because it left out people who do not use email, maybe. You know what? Just because, you know, there are people who have a computer and they don't use email. They probably still do the old-fashioned thing of calling people. Or writing a letter, yeah, imagine that. So, if you're contacting people with a computer on their email, you're leaving out, what about all the people who don't even use one? Shouldn't you find out if there are people who, okay, and maybe we need to finish this, and those who do not use a computer. I mean, you got to come up with a better way to contact people than on a computer if you're talking about them using a computer. You need to call them, mail them, I don't know, come up with a different method. Okay, a researcher asked 5 students if they think the cost of school lunches is too high. 5 students. 4 of them say it is. Explain why the following statement is misleading. 4/5 of all students think school lunches are too expensive. Yeah, they only sampled. The sample size is too small. Yeah, the sample size is too small. They did not sample enough students to make that conclusion. Well, then which would be more trustworthy? A survey of 10 people or a survey of 100 people? 100 people, that's kind of like, yeah, a given, isn't it? Survey of 100 people. The more the merrier. No, the better survey because you get a better representation. The more that you sample, the better representation you will get of the true picture. It can't just be, you know, like, especially if it's Valley City High School, and we are really going to, we want to find out what do you think about getting another 5 minutes added on even next year for your lunch hour? If they only surveyed the 7th graders, and they only surveyed 5 of them, and 4 of them say, you know what, no, I'm down